Welcome to the course Business Analytics and Data Mining Modeling using R. So, in this lecture we will start our discussion on our next module and next topic, that is performance metrics for prediction and classifications. In this particular lecture we are going to focus on these two tasks, prediction and classification, and how different model, whether they are prediction model or classification models, how their performance can be evaluated. So, let us start our discussion. So, first of all we need to discuss why we require performance metrics. So, because different models, different methods can be applied to different prediction and classification tasks. So, therefore, how do we select the most useful or the best model from all those candidate models? So, for that we would require some metrics which can help us in deciding, which can help us in making that decision, finding the most useful model or finding the best performing model. So, comparison of candidate models can also be done. Sometimes, as we have talked about, that it might not be several different methods, just one method and different variants of it, because of the different configuration or different options that we select for different variants. For example, one simple example could be the same model, regression model, with different set of predictors could be run on the same data set. So, therefore, for the same method we will have a number of candidate models, each having different set of predictors. So, therefore, it becomes important for us to have some metrics which can help us in deciding which one is the most useful model or the best performing model. So, in this particular lecture we are going to focus mainly on the classification and prediction and the relevant performance metrics. So, we will start with classification. So, classification, generally this is the metric that we use, probability of misclassification. So, if the probability of misclassification is on the lower side, so that can help us determine whether a particular model is useful or performing, giving better performance or not. So, for different candidate models we can look at the probability of misclassification, and then how we can actually compare their performance or compare their usefulness for the task at hand. Then naïve rule for classification performance could be the most prevalent class. So, for example, if we have 3-4 classes for which we are trying to develop a classification, trying to build a classification model. Any record can be classified, any new record can be classified to the most prevalent record. If it is classified to the most prevalent class, then that is called naïve rule. So, this serves as a benchmark. So, other models, other methods, their performance can be compared with respect to this benchmark. So, if we do not run a model, if we do not include the predictors information, the relationship between predictors for our model, relationship between predictors and output variable in our model, and just use the naïve rule, which is the any record irrespective of the information that is contained in predictors, right, we just assign this particular record to the most prevalent class. So, for example, if there are 3 classes and the most prevalent one being class 1, which is having, or let us say out of 100 observation, 80 observation belong to this class, and then the remaining 15 belong to class 2, out of remaining 20, 15 belong to class 2, and the 5 belong to the class 3. So, the most prevalent class being class 1, 80 records belonging to this class. So, therefore, any new record can be easily classified to the class 1 and will also have a good amount of accuracy of based on this naïve rule model, 80 out of 100. So, now any new method that we apply for this particular classification task, classifying a record into these 3 classes, class 1, class 2, class 3, should actually perform better than the naïve rule. So, naïve rule serves as a benchmark and then we can look at the probability of misclassification and compare different candidate models to find out the most useful one or the best performing one. Now, there are a few matrices which have been developed based on naive rule. So, therefore, these matrices actually use the naive rule and use it to build a matrix that can be used to compare the usefulness of different models. So, one is multiple R square. So, what is multiple R square? More detail we will discuss in coming lectures, but to give you a brief definition, that multiple R square distance between fit of model to data and fit of naive rule to data. So, that is why we are saying that this is a matrix based on naive rule. So, distance between fit of model to data and fit of naive rule to data, that is actually looked at in multiple R square. If we want a naive rule kind of equivalent for prediction task, if we want a naive rule equivalent for a prediction problems or prediction task, sample mean could be the 1. So, if we are looking again, if we are trying to predict a value for a particular variable, and we are not interested in looking the information that is there that can come from predictors, right? We are ignoring the predictors information, then simply the mean value of that particular output variable can be taken, and for any new record that mean value can be assigned to that record. So, that could be the naive rule equivalent for prediction task, because the mean value is the centralizing value for a particular variable, and therefore, any new variable we can expect it to lie around that mean value. So, the error would be minimum if we do not use any other predictor information. So, simple sample mean could be a naive rule equivalent for prediction task. Now, let us come back to our discussion on classification. So, classification matrix is generally used to compute different performance matrix for classification task. So, you can see how a classification matrix is displayed. You can see here. So, generally we will have predicted class. So, if we so in this particular case we are talking about two class scenarios where one class is represented by 1 and the other class is represented by 0 value. Similarly, actual class represented by 1 and 0. So, that we have predicted class and actual class and we have different numbers. So, this is based on once the models have once different models have been applied. So, for a particular model Nij represents the number of class I cases classified as class J cases. So, if we look at N11, so this is the number of class 1 cases classified as class 1 cases, which is the true classification, right. If we look at the next number, this is number of class 1 cases classified as class 0 cases. So, this is the incorrect classification. Similarly, we look at the second class, that is class 0. So, this particular value N01 is number of class 0 cases classified as class 1 cases. So, this is also incorrect classification. Our next value is N00. This is number of class 0 cases classified as class 0 cases. So, this is the correct classification. So, if we look at the diagonal values N11 and N00, so these two values are actually the correct classification by the models. So, these numbers some of these numbers represent the correct classification, and if we look at the off diagonal values, that is N01 and N10, they represent the incorrect classification. So, some matrix can be computed based on this classification matrix. So, generally most of the techniques, most of the methods that we apply that we use for a classification task, they generally result in classification matrix. So, finally, this classification matrix is then used to compute different matrix and then evaluate the performance. Let us another important points about classification performance is that while we build our classification model on training partition, it is the so therefore the while we are building our model on training partition, so the model will fit the data a bit more, and therefore as we have been talking about, it is not recommended to test the performance of the model on the same partition. So therefore it is the validation partition classification matrix that is generally used to judge the performance of a classifier, performance of a model for classification task. Now we can still develop a training classification matrix, but it could be used to compare with the validation partition classification matrix to detect overfitting. For example, it is expected that model would perform slightly poorly for the validation partition because the model was built on training partition. So it will fit the training partition data more accurately. So therefore the performance might go down for the newer partition, that is validation partition. However, if there is too much of gap between the performance numbers of validation partition classification matrix and training partition classification matrix, that might indicate overfitting, that the model has overfitted the training partition, and that is why the performance on validation partition has come down much further. So that is how that is one way to detect overfitting. If the numbers for validation partition classification matrix is on the lower side, but not that much, there is a small gap, then probably the model is stable and performing, the developed model is performing well, might perform well on the new data as well. Now there are some performance metrics as we were talking about, which are based on classification matrix. So these are as simple as misclassification rate or error and accuracy. So if we go back to the classification matrix that we discussed just a bit before, you can look at the opt diagonal values n01 and n10. So these are the misclassified number of cases. So misclassification rate or error would be the proportion of total number of observations which are misclassified. So these are going to be n01 and n10. If we look for the another metric that is called accuracy, so therefore the classes, the observation classified into their actual classes. In that case, if we go back to the matrix, we would see n11 and n00 or these two diagonal values, they represent the accuracy. Proportion of these numbers out of total observation represent the accuracy and determines the usefulness of a particular model. So misclassification rate or error or accuracy numbers can be used to compare the performance of different candidate models. So these are the formulas for these two matrices. So performance matrix based on classification matrix, you can see error is computed as n01, so plus n10 divided by total number of observation, that is n, and accuracy is 1 minus error, that is n00 plus n11 divided by total number of observation n. So these two metrics can actually be used to compare the performance of candidate models. Another important concept related to performance matrix is the cutoff probability value. So cutoff probability value is, so we talked about the earlier we talked about the probability value. Earlier we talked about the probability of misclassification. So let's come back to the same discussion. So how do we assign different cases? How do we assign different cases to different classes? So generally the data mining methods or statistical method, generally they compute using the model, they compute the probabilities values for different records. So if there are two classes, for example class 1 and class 0, for each record will have probability value of that record belonging to class 1 and probability value of that record belonging to class 0. So how do we assign that record to a particular class? So cutoff probability value is the one that is used to do that, to perform that that assignment. So there are different scenarios how this cutoff probability value can be used. So, first one is when accuracy for all the classes is important, and that means we want to correctly classify all the cases irrespective of the class. That means they could belong to class 1 and class 0, but we are trying to classify them. If the record belongs to, if the actual class of a particular record is class 1, we want to classify it to class 1, and if the actual class of a record is class 0, through our model we want to classify as class 0. If that is the scenario, if that is the that is what we want, then a particular case or observation can be assigned to the class with the highest probability as estimated by the model. So, as we talked about, for every case or observation we will have number of probability values for each class. So, for two class case, class 1 will have a probability value, for class 0 also will have a probability value. We will compare them, and the class where the probability value is more than the other value, same value for the other class, then the case would be assigned to the class having the higher probability value. Now, in some other scenarios, accuracy for a particular class of interest is important. So, there could be a particular class where we might be interested in identifying cases belonging to that class a bit more. So, we would be interested in identifying ones a bit more, even if it comes at a higher misclassification records for zeros, class 0 records belonging to class 0. So, in those situations the assignment would happen in a different fashion. So, we will not be assigning depending on the higher probability value. So, what we generally do is, a case is assigned to the class of interest if probability for the class is above cutoff value. So, we will define a cutoff value in such cases, and if the value for class of interest is higher than the cutoff value, that particular case or observation would be assigned to that class of interest, otherwise it would be assigned to the other class. So, if we talk about two class model, the default cutoff value is generally 0.5, that is principally similar to the naive rule, because if there are two classes, if a particular probability value is more than 0.5, so therefore that is the more prevalent class. So, that is how the assignment is going to happen. If we look at the other scenario, when accuracy for all the classes is important, even there when a record is classified to the highest probability value class, there also we can see the application of naive rule, because higher probability meaning, highest probability meaning, that is the most that is in a way more prevalent class. So, therefore, that particular record is being assigned to that particular class. So, the idea is similar to naive rule when we talk about the assignment based on the probability values. So, we will do an exercise using Excel. So, let us open this particular file. So, what data we have is, here are 24 observations, as you can see, row number 2 to row number 25 we have 24 observations, and for each observation we have the actual class, whether the particular observation or case belong to class 1 or class 0. So, you can see that is appropriately indicated here, 1 or 0 for each observation, and we also have probability of that particular class belonging to class 1. So, that probability value is given there. Probability of a class belonging to class 0 would be 1 minus this probability, because we are discussing two class scenario. So, these probability values are here also, and if you see, they are arranged in the higher probability to low probability sequence. They are arranged higher probability to low probability sequence. You can see if we cutoff probability value for success, the default value, that is 0.5 as we discussed before. So, we look at the actual class 1, it is going to be correctly classified as class 1 because the probability value for this particular case is more than 0.5. Similarly, for second observation, this is also going to be correctly classified having more than 0.5 value. Same is for this case. If we keep going on in this fashion, we will reach to record or observation number 8. So, there you will see that even though the cutoff probability value is 0.686, which is more than 0.5, the actual class is 0. So, as per the probability value, it would be classified as 1, but the actual class is 0. So, therefore, this will be this is going to be an incorrect classification. If we move further, again we get the correct classification, more than 0.5 value and correctly classified. If we go further, again we encounter another misclassification where the value is for the observation is more than 0.5, but incorrectly classified. Similarly, now further as we go down, probability values start becoming less than 0.5 and the classification also start becoming 0. So, in this case observation number 13, case number 13, value being 0.49 and the observation being correctly classified as class 0. Similarly, if we go down, there are few misclassification. For example, this one, record number 15, row number 16, this is 0.46 value and this is incorrectly classified as this is going to be incorrectly classified as 0, but the actual class is 1. So, we can say if we want to count the number of ones and 0 in this particular example that we have, number of ones are 12 and number of zeros are 12, and if we look at the based on this class cutoff probability 0.5, if we construct the classification matrix. So, these are the values. So, classification matrix, we can see that 10 observations are which belong to the, for example, owner, for example, their owner is 1, non-owner is 0. So, 10 observations are correctly classified, 2 observations which are actual owners, they are incorrectly classified. If we look at a non-owner class, so 2 observations which were actually non-owner, they were incorrectly classified as owner, and 10 observations which were actually non-owner correctly classified as non-owner. So, these are the numbers and the accuracy values can be computed. You can see here the diagonal values E6 and F7, and they are divided by the total number of observations and we get the accuracy. Similarly for error also. So, we have created, so here in this particular case we have created one variable table in Excel, and for these value range from 0 to 1 at every 0.05 interval. So, as the cutoff value changes from 0 to 1, we have the accuracy and overall number. If we focus on these values 0.25, we will have the accuracy number as 0.63 and 0.38. If we go back to the default value 0.5, 0.83, so you would see that at the default cutoff value the accuracy is much better. For 0.25 it was 0.63, for 0.5 it is actually 0.83. So, default cutoff value accuracy numbers are much better. If the cutoff value was 0.75, then you would see again the accuracy is comes down from the case of 0.5, now it is 0.75 from 0.83. So, whether we move reduce the cutoff value from 0.5 to 0.25, the accuracy goes down, or whether we increase the cutoff value from 0.5 to 0.75, again the accuracy goes down. Now, if we look at the classification matrix, so you would see right now the predicted. If we look at the predicted class, right now 12 are being predicted as owner and 12 are being predicted as non-owner when the cutoff value is 0.5. If we change this cutoff value to from 0.5 to 0.25, you would see the classification matrix has changed because of the appropriate formulas being used in those cells. So you would see now in the predicted class 19 observation have been classified as owner and only 5 observation has been classified as non-owner. This is mainly because of the lower cutoff value 0.25. So therefore more number of observations are being classified as ones, and therefore we see more number of owners, 19. So this jumped from 12 to 19, and that is why there is a drop in the accuracy value. Similarly, if we change the cutoff value to 0.75, you would see the numbers have changed in the classification appropriately, and now you would see that there are more non-owners more observation being classified as non-owners. We would see that only 6 observations have been classified as owner and 18 observations have been classified as non-owner. So you would see that because the cutoff value is more than 0.5 on the higher side, so therefore fewer observations are being classified as ones and more observations are being classified as 0. So let us go back to our discussion. So if we move away from the cutoff value of 0.5, we move to 0.25 or 0.75, then in each case the accuracy goes down. So in each case the accuracy goes down. So why change this cutoff probability value from 0.5? There could be 2 reasons. One is we have a special class of interest, and therefore we are interested in identifying those rare cases or those cases belonging to a special class of interest a bit more, even if it comes at the misclassification of higher misclassification rate for other class. Similarly, another reason could be asymmetric misclassification cost. So if one particular class, the cost of misclassification for that particular class would be much higher than the cost of misclassification for some other class. So therefore, because of this asymmetric misclassification cost also, we would be interested in finding out more of the more of the observation belonging to class having higher misclassification cost, and that would require us to move away from our default cutoff probability value of 0.5. So next question would be when to incorporate change in cutoff value, when do we change? So so for example, if the example that the exercise that we just went through in Excel was we already had we had already run the model, we had the actual ones and 0, but we also had the probability values as estimated by the model. So you would see that the exercise of changing the cutoff value from 0.5 to 0.25 or 0.75 or other numbers to one variable table in Excel, that was done after the model has been selected and we had the probabilities value, and then we were trying to see how the results would change if we change the cutoff value. So one situation would be after final model selection, we can incorporate change in cutoff value because we will have the probability values. Most of the techniques they estimate probabilities values also. So therefore it is easier for us to change the cutoff value and see how the results are changing. Now another situation could be before model derivation. So we can incorporate the misclassification cost that could be there at the model derivation during the model derivation steps itself, and that would ultimately determine the results. Now when we have a special class of interest, the performance metric like accuracy and error might not be useful. So few other metrics are popular when we are specifically interested in a particular rare class or a particular class of interest. So these metrics are sensitivity and specificity. So we will discuss them in more detail in the next lecture. So we will stop here. Thank you.